The internal auditors of a large company are interested in the system by which incoming invoices are processed. They take a random sample of 50 completed invoices and check them in detail for correctness of procedure. 4 are found to be defective in some way. The auditors then suggest some modification to the procedure, and these are implemented. Allowing time for the clerks to adjust to the new procedure, the auditors then take a random sample of 60 completed invoices. This time, they find 3 incorrect ones. Is there any evidence at 5% level of significance that the new procedure has improved the error rates? First of all, we can find that null hypothesis is P1 equals to P2, and alternative hypothesis is P1 more than P2. We can see that it is a positive one-tailed test. Significance level is 0.05. P1 hat equals to 4/50th. P2 hat equals to 3/60th. P hat equals to 4 plus 3 divided by 50 plus 60, and it equals to 7 divided by 110. Since N1 and N2 are large, so P1 hat minus P2 hat are normal distributed. After checking the table, we can know that Z should be more than 1.645. From the formula, we can know that Z equals to P1 hat minus P2 hat minus the mean of P1 hat minus P2 hat, divided by the standard deviation of P1 hat minus P2 hat. Z also equals to P1 hat minus P2 hat minus 0, divided by the square roots of P hat times Q hat divided by N1, plus P hat times Q hat divided by N2. After calculate, we can get the answer is 0.6418. So we can get the answer is do not reject null hypothesis.
Good afternoon, my name is John Chak Lam from Group 5, and I'm going to talk about Mock 1 question 4C. The question is about a health spa has advertised a weight-reducing program. A somewhat overweight executive is interested in the program, but is skeptical about whether the program can help participants to reduce an average of more than 70 pounds. The spa allows him to select randomly the records of 10 participants and record their weights before and after the program, and the above data is shown. Assuming normal population, is there any evidence to suggest that the program can reduce on average weight of more than 70 pounds at 5% level of significance? So we can use the hypothesis to be the solution of this question. First, we can let hypothesis 0 mu d equals to 70, and then let hypothesis 1 mu d greater than 70. Alpha equals to 0.05. Since the distribution is normal, sample equals to 10, which is smaller than 30. We can use the t-test. We can find out that the freedom degree equals to 10 minus 1, that is 9. And from the t-distribution table, t equals to 1.833. We can later find out that the critical region equals to 21.833. After that, we can find out the sample mean of difference between two groups, that is equals to 19.7. Sample standard deviation similar to 4.398. Calculated by formula t equals to 1.994. Since 1.94 is greater than the 1.833, it is in the critical region, and hypothesis 0 is rejected.
Hello everyone, I'm Evie. I'm going to present question 4B in mock examination 2. The question is as follows. BM Group is considering opening a restaurant in a new district, and the group decides to carry out a research to make sure that the restaurant will make profits. Average family income of residents in the district is believed to be a good indicator of profitability, and a level of 18,000 at least as is required. The group then takes a random samples of 64 households in the district and finds an average monthly income of $17,100 and a standard deviation of $1,200. At a 0.01 level of significance, test whether the group should open the restaurant in the new district. For the solution, first of all, the question has given that the sample size is 64 households. The sample mean is $70,100, and the sample standard deviation is $1,200. The mean family income is equals to $18,000, so H0 is mu equals to $18,000. H1 is mu larger than $18,000. For the level of significance is equals to 0.01. According to central limit theorem, sample size larger than 30 is claimed as large. Therefore, the set distribution table is used, and I found that the critical region is set larger than 2.33. By testing the statistic, set is equals to 70,100 minus 18,000 over 1,200 divided by root 64, then gives the answer of negative 6. Because of this, H0 is rejected.
Okay, welcome everybody. Here's a question for C. And the question is, a market researcher is comparing the characteristic of buyers and non-buyers of a particular product. Independent samples of the buyers and the non-buyers are selected. In the age of responding are listed below. Here's the list. And test whether there is a differences between the mean age of buyers and non-buyers at 5% level of significance. And we need to state this assumption. Thank you. For this question, we have few steps to do so. First, define the hypothesis. Second, decide which test we are going to use. Then calculate the degree of freedom. After that, state its decision rule. Last but not least, calculate the test statistic. And finally, state the result and conclusion. So before we go into define the hypothesis, I want to say that mu1 is the mean of buyer groups and mu2 is the mean of non-buyer groups. So now we can just define the hypothesis. I would say HO or H0 is mu1 equal to mu2, or you can say mu1 minus mu2 is equal to 0. And of course, H1 is mu1 is not equal to mu2. And since we don't know both of their standard deviations and the number of group is less than 30, so we gotta use the t-test. Okay, here's the t-test formula, and before I use it, before I calculate the t-test statistic, to remember what we got to do. Yes, thank you. We are going we are going to calculate the degree of freedom. Yes, we are going to use the more complex, the bigger formula here, which is next to the t-test formula. And before we use it, we need to find out the variance of both groups. And S1 square is the variance of the biased group, and after calculation we got the answer is 100.8, and S2 squared is the variance of non-biased group, and after calculation you have a 185.5 something. Then congratulations, now you can just put two numbers to find out the degree of freedom. And you can find that the degree of freedom is about 35, which is larger than 30, obviously. And we need to use the Z value to construct the critical region. And this step is to state the decision rule. And as the question mentioned that the difference between the mean age of both groups is at 5% level of significance. So 0.05 in the Z table, you can find that the Z value is 1.96. So here we can just state the decision rule is if the answer of t-test statistic is less than negative 1.96 or greater than 1.96, we need to reject it. So after calculation of the test statistic, the answer you'll find that it's negative 1.955, which is not included in the critical region. So the conclusion will be do not reject HO. And thank you very much.
Hi everyone, my name is Ron Yip. Today I'm going to talk about mock examination paper 2, question 5A. The question is about a management training program is organized by a company to teach supervisory skills. The participants attempted the examination before and after the training program with high scores representing better supervisory skills. A random sample of 10 supervisors is selected and their examination scores are shown below. I will have to test whether the management training program is effective in improving supervisory skills at 5% of level of significance. State the assumptions. So now I let D as the difference between post-test score and pre-test score. So for the null hypothesis is mu D equals to 0. For the alternative hypothesis is mu D larger than 0. So for the level of significance as mentioned in this question, it should be 5%, which is also equals to 0.05. So I first calculate the summation of D, which is 69, and I also calculate the summation of D squared, which is 741, and the random sample size is 10 this time. So the mean of D is equals to 69 divided by 10, which is 6.9, and the variance of this question is 29.4333, and the degree of freedom, as I found, is 10 minus 1 is equals to 9. And according to the table, so t value is larger than 1.8333. So I test this statistic and I found the t value of 4.0219. So therefore H0 is rejected, and it is found that the management training program is in fact effective.